with that piece of arbitrary code. So here's somebody's code, and they're trying to collect people for some sort of team or other, and they're trying to collect some eggs in order to get a dozen to be able to sell. Okay, and so they've written some code for some reason in the same file. Maybe they're going to throw the eggs at the people, I don't know. And so we've got fairly simple looking code, and let's just imagine that that piece of code just doesn't happen to be there. It's someplace farther on down in the file where you can't see it, or maybe it's in another file. And then for some reason, well, I guess let me just do this the other way around, which would make a little bit more sense here. I'm going to move the people up here where we can see them. And so now all of a sudden we've got the people up there, and then somebody decides, instead of 12 people, maybe we'll play, I don't know, rugby sevens instead. Okay, and so they sort of get worried that there might be more 12s in here that they need to change, because chances are pretty good if we were playing with 12 people up here, we're probably going to have some other code that's playing with 12. So just to be sure, let's just go through and do find and replace, and find all the 12s and replace them with 7s. How about that?
Why would you want to do that though? Like, what if you accidentally change some 12 that you did not?
That being the point. What's happened here is that someplace along the line, I didn't realize that 12 meant something else farther in the code, and now all of a sudden I've basically introduced a bug on eggs, because now a dozen isn't actually a dozen. Okay? And it's fairly typical that programs end up having constants in them for various reasons, or numbers flying around all over the place. And this sort of thing can happen quite often. And like I say, not in this case, it was just in one file, but somebody may come along and go, well, Java thing, I've got 12 files here, I best, or 15 files, I guess I better go change all of the numbers in all of the files where I've got this 12, because I've been working on this team-based thing for a while now, and then they just accidentally hit the 12 for eggs in some file someplace. And it will take a long time to find that bug. So what we'd like to do is find some way to prevent that from happening. And the first shot at it is to say, well, it would just be handier if these things had names to start with. So if I did int eggs per dozen is 12, and people on team is 12, then at least here I could be, if this would start to make more sense, even by saying if people on team for that one, and this one becomes eggs per dozen. Okay.
Just change the variable name.
Eggs. There we go. Okay. So notice that there's two things happening. In the first case, it makes the code much more readable. It's because the number has gone away and been replaced by a concept that's a lot easier to understand. And in the second place, at least now if you go and fiddle with things, it won't be quite as bad. It's just all in one place. But again, suppose that those are separated in files or in time, you still have the same problem. And so the goal of the game here is you want this variable to have a value, but after it's got that value, you don't want it to change. So essentially what you want is a constant for this. And another reason why you might want a constant is so that someplace farther in the code, people don't go accidentally use people on team when they meant people so far, and they go people on team equals 4, which would also sort of ruin things if they really meant the other variable. Okay? So we essentially want that 12 to be a fixed number. So what we'll do is we'll go up here and we'll do public static final int people on team is 12 and public static final int eggs per dozen equals 12. Okay, and now what we'll do here is we'll use those words, so it looks something like this. Oops. Okay, and we won't use those other variables. So a couple of things have happened here. The first thing is that all of this gobbledygook here just basically means it's a constant integer in this case, right? And so the static is there because they're at the top of the file, so and public is there so that anybody can see them, and that's just normally the way you'll see them. The constants will be written at the top of the file on purpose, because now when you want to go change things, you change them in one place at the top of the file, and it will just magically work all the way through. Okay? Because there's no numbers that appear anywhere else other than at the top of the file. The second thing is that now when you try to do something like people on team is some weird number, then you get this error message here that says, oh no, sorry, that's a constant. It's already gotten a value. It can't be changed anymore. Okay? So now the compiler is going to prevent you from changing that value to something else. Okay? I'm just going to leave that in there to remind you that you can't do that anymore. These things are typically written as a convention in uppercase with underscores between them, just to remind programmers that it's a constant. Okay? And that convention has been around since the C language, so you'll see this in both C and C++ is sort of the standard way of doing it, and Java's just carried on that convention. Okay? So rule now is any numbers that you have get written at the top of the file in uppercase as constants so that they can't be changed anywhere but at the top of the file, and you don't expect to see any numbers appearing anywhere in the body of your code anymore. The exception being 0, 1, and -1, maybe 2, maybe even 3, okay, depending on what it means. Okay, but other than maybe those exceptions, the rule is always give everything names. It reads better, they can't be changed except in one place. They're easy to change when you go about changing them. You just go to the one place, change whatever you need to be done. If you needed those values to be seen from other files, then what you would do is you would make a class that had nothing but those names in it, and then people would be able to use those constants anywhere by just importing the file, basically. Okay? So that's step number one. Okay, and it's not a bad solution, but it has one subtle problem. And the subtle problem is that people are still allowed to do something like this. Well, actually, we'll leave it for a second. I'll get to the subtle problem in a second. Let's just try something else here. Switch statements. Have you seen them in other languages before? The case statements? Okay, let's do the Java version of a switch statement. What do we want to do? I guess that's probably not the best thing. Let's just make up something here. We'll do it this way.
Does it always have to be on all caps like that?
Yep. It's just, like I say, it's just a convention. I'm going around the clock here on purpose. Okay. So there's the other way that you see a group of constants all together, and quite often what you'll also see people do, just to remind everyone that they all belong together, is you'll see people do this instead, which is probably a good thing. Okay. So there's a group of numbers that all are names that all belong together for some reason, and I gave them all very similar names on purpose just so that when I used it, things would be fine. And then we can go down here and we can say something like int current direction is direction dot west, for instance, to assign a value to it. Oops.
Underscore.
Direction underscore west, like that, and then you would do switch on current direction, and then we'd have the various cases in here. Case direction north, a semicolon, and then you have whatever you want to do here. This can be multiple statements, but I'm just going to put in a print line in here. And then I'm going to do a bunch more of these. Oops. Normally there's a break there to end the switch statement for that case. And then we'll just do a couple more here. And this is going to be east, south, and west with their appropriate words. Okay, so there's a sort of a standard case statement, and they're the same, like I say, in C, C++, and Java, more or less. They have the same heritage, and so there's the output heading west. Okay, well, now that you've seen a switch statement, suppose that somebody comes along and accidentally does that. Does it still work?
Yes.
Okay, because that's just, the number 3 is just replaced for the variable there. What happens if they do that?
Break.
It won't work. It won't do anything.
Nothing will happen in this case.
Because there's
Oops.
no error case.
You can add a default case here. In which case your code will at least print out not valid direction. But I actually prefer that you couldn't do that at all. Okay? Really what I'd like to see is that that variable that we have up here can only ever be assigned the numbers 0 through 3, and if I try to assign anything other than the numbers 0 through 3, the compiler should catch it as an error. Okay? So I shouldn't be allowed to do that at all. And so the problem with this idea of just using constants is that because they're integers in this case, still perfectly happy to go along and change the integer to any value you want. It's not restricted to just any of those 4 values. Okay? So let's try something else. The solution to that problem, and I always fail to get the syntax exactly right, so I'm going to steal a copy from someplace. And just to even save you the typing pain, I'm going to do that. Okay? So this is the modern way of doing the constants. And in this case, I've just gone in and put those same values in. I guess I should make them go in the same direction. Okay? And now you can essentially do the same sort of thing. So I'm just going to come down here and maybe steal all this just to show you that it almost looks the same. And replace this with, just reuse that variable. Current direction equals directions dot. Oh, look at that. As soon as you type the dot, the IDE gives you only the choice of the valid things. So we'll just stick that in there. And this is going to be like a direction, just to make it look a little bit different. Did I do it right? Directions. Okay. So notice that that thing acts like now a Java class. And because it's a class, you can now use the pieces out of the class, and then you can do a switch on a direction, and then this becomes if I spelled it right. What doesn't it like here? Did I spell it correctly? What did I do wrong? Oh, yeah. Nope. Oh, ha, yeah. I remember now. How about this? Even easier. Compiler already knows. Okay? So now you end up with a piece of code that looks like that instead. Advantage of this one, it says, no, sorry, you can't do that. Okay? So it knows that those are the only acceptable values, is things that basically come out of that thing that's actually a class, and now it won't let you set it to anything other than the values that it has to be. Okay? So no way that you can possibly get it wrong. So I'm just going to leave that in there as a reminder for you.
Unless you forget the directions
Okay?
type.
Okay? So that is old school. has some problems. This is the new way of doing the same thing, really. And as a matter of fact, all the compiler does is it just basically north has a value of 1, east ends, or 0, east ends up having a value of 1. It's exactly the same thing internally, but the compiler just prevents you from doing bad things with those, and you get to use the actual names, and they're grouped together and all that sort of fancy stuff. Okay, so it becomes the much better option for doing things. And you can also do things like this for directions, a direction in directions dot. Can't quite get an iterator out of it, but we can come close. Oh, I used that one. We'll just print out some direction. And now when you run this thing, it can even be used to actually print out the directions, which also appear in capitals. Okay, so you can run for eaches on them, because now you can go through all of the directions, and it just goes through only the ones that are possible and none other. Okay, so you can use them in case statements, you can use them in for eaches, and life is really good. Okay, questions about that? Okay, let's try a recent addition to Java. Let's do, let's try a string with selection equals Fred, switch on selection,
Selections.
thank you. Let's do something like this. Whatever you wanted to do with Joe. And we can also do another one. Normally you'll see blank lines between that stuff, and let's do Fred here. And one more, just to be a good person and put the default in. By the way, it's almost always a good idea to put the default in, even if you don't, even if you expect that there will never be one. Okay,
in case you break something.
and you just never know. It's just always a good practice. Okay, and notice that the compiler accepts that also for strings. It never used to, so it's only the very new versions of Java where they've added that idea. Usually these switch statements are restricted to anything that's a constant. Okay, so that means basically integers for the most part. Okay, and the recent addition is to be able to do strings, which you can translate into a constant. And so they've modified the compiler to make that happen.
Could you not before have a string as a constant?
No, not until Java 1.7, I think, one of the latest ones. You have to do some extra antics to make it work for strings.
What's the difference between this and like some else ifs?
The question is, what's the difference between if this and else ifs? This tends to be easier to read, And this style tends to be used when you have a, like a choice of 4 or 5 or 6 things that are all somehow related. Else if tends to be used for things where you're trying to go within a range, for instance. So, is it between these values or between these values or between these values, or you're throwing, larger amounts out. Okay? And we're still on the business of avoiding else ifs just because this is typically much easier to read. Okay? Eventually, if you get a lot of these, you stop doing this and you replace it with a table of values and you write a loop to go through and do the comparison against a table of values. So in some senses, it's usually used for, call it, small tables of constant values. Okay, so that makes all of that work. We've seen the switch statements. Case statements, what else can we do here that looks like fun? How about arrays? This thing is going to get a little big and ugly, but that's okay. We haven't used arrays, but if you wanted to use one, you would do an integer, I don't know, grades. If I wanted to do just one grade, I would do equals 6. If I want to do many grades, you use open and close brackets like that. And on this side, we would do new integer for however many values you wanted to keep. Okay. Now, the syntax actually allows for you to put this empty bracket on either side to say more than one of, is really all that it's saying, right? And then the new tells you how many of those things you're actually going to allocate space for. This is typically what C programmers do and C++ programmers do, and the Java people will always end up doing it on that side. Okay, so this is more than one integer is the easiest way to think about it. Once you, as with any other arrays, once you pick that size, you're stuck with it. You can't make it bigger without having to go allocate a new array someplace else, copy all of the values over, etc. So the big problem with arrays is typically managing how much stuff is in them, because this specifies the maximum, not the number that are actually there. You just end up with 4 empty spots, and you usually start filling them from the beginning to the end. Okay? So the whole idea of using array list is that it's a list that uses an array underneath, and you can actually see that when you look in the debugger. You can go find the array, but what will happen is the list is smart, and when it runs out of room in the current array and you add the extra one, it will just quietly go make a bigger space, copy things over for you, and you just never know. Okay, so array list is really a conveniently growable array that just grows as large as necessary. Okay, so normally you try to avoid using arrays because of that. The only people who typically use fixed size arrays, or who should be using fixed size arrays now, are math type people, because they're more efficient for accessing the values of variables out of this array than they would be if you had to use a list and go through a function call for everything, etc. Okay, but that's what they look like. So now you can turn around and you can say, okay, I'm going to say that grades sub 5 equals 57, or I guess I better make it within bounds. Grades sub 2 equals 57. Okay, so you can fill any position that's there, but normally you would expect that people would do the right thing and start filling it from the 0 positions first. which means one of the rules is with arrays is that whenever you make an array, not only do you have to worry about what's the maximum size I created, but you also have to worry about how many positions have I filled so far, right? And so it's not unusual to do something like, say, int next available slot in that array. Do something like this, equals 1. Okay, so now you've got this idea that I'm tying together how many items are there, or where am I going to put the next one, along with that value there, and those two variables end up being paired together. And all that ArrayList does is it manages those two ideas together for you, so it always keeps track of what's the size, which is next, what's the next available position, and if it runs out of room, it makes it bigger. Okay. And with Java, if you try to do grades sub 57, or I guess 43, equals some value, what happens?
Index does not exist.
Oops. Let's just run it and see. Program dies. On purpose, because there is no position 43 in that array. And so the error message says that you ran off the bounds of that array on that line. Okay. By the way, in older style languages, particularly C and C++, that might or might not continue to work. Okay. So if you run off the ends of an array in C, for instance, if there happens to be a memory location available after that portion of the array that's suitable for writing, you just write in that spot. Okay, which is sort of bad news because it means you've scrawled over some arbitrary point of memory that probably belongs to something else. And you've got a bug in your program that's very difficult to find. By the way, that little thing there in C in particular, if you've heard the security issue called buffer overflow. In a buffer overflow, essentially what somebody does is they replace, when they find some piece of code that accidentally allows you to do that in somebody else's code because they're not checking array bounds, what they'll do is they'll fill something off the end of an array with opcodes, with assembly language opcodes, and then convince the that code to be executed in some way. Okay, so that's how you play sneaky games with buffer overflows. Okay, so Java tends to be have a lot more security built into it, so you can't do that. Your program will just die if you try to run off the end of the array, which is a good thing. Okay, in C, it's basically a crapshoot as to whether or not your program dies. If you're lucky, it will, and if you're unlucky, it will just scroll over some arbitrary portion of memory.
Why did they allow that in C?
The reason they allowed that in C is just basically originally started out as a fancier version of assembly language. And so it was more or less one for one, and they left that ability there. And it was back when compiler writers weren't as smart as they are now, and they didn't have virtual machines and all of those fancy things. And so it was just, you can do the same thing in assembly language. If you accidentally put something into a memory address that's not right, as long as that memory address exists, that's fine. It just gets scrawled into the wrong place, which causes all sorts of weird problems. Okay. So there's something that you can do with arrays. The only other interesting thing about arrays is that if you look at grades and type dot, one of the things that you'll find it has is length. And so grades.length is the actual size, the originally allocated size, that 4 of the array. So you can print it out. Okay, and that will be the same 4 that you started with as soon as I get rid of bit of nastiness. Okay, so there's the 4. So that makes it possible, for instance, to write a loop I is less than grades.length. So you don't have to carry the 4 around with you.
-1.
And we can print them out. So currently we've only used the first slot in the array, so there's the 57. By the way, somebody immediately said -1
Yeah, I realize.
on that thing.
Less than.
The really simple rule for loops is that almost every single loop that you write has the intention of going through all of the things, and if you start at 0, that will always be less than. Okay? If you start at 1, that will always be less than or equal to. And if you write anything other than those two combinations, you're pretty much wrong. And as a matter of fact, even if you write =1 to whatever, chances are pretty good it's pretty much wrong. Okay? So this thing, whenever you write a loop in C, Java, or C++, just always write it to go from 0 to less than maximum, and probably 95% of the time it will be exactly what you want. No reason to do anything else. And so all of the weirdness that they teach you about counted loops, about going up by 2, down by 1, all of those sorts of fancy things that you can do never happen in real code. And if you're doing them, it's probably a mistake. Okay? So there's lots of ways around it. It turns out that you can also do for int and int in grades and that also works. Which, if you really want to go through all of the values in an array, is the better way to do it, because it's a nice simpler syntax and you don't get confused with should I do the first or did I do the last. Okay, so they retrofitted for each to print out, to work properly with arrays of things in the latest version. It never used to be there in Java. Okay, so when they put the for each in, they made that work also. Which is a good thing if you're printing out all of them. It's a bad thing if you're printing out just some of them. So for instance, we don't really mean grades.length here. We probably only mean the slots we've used so far. So in this case, we really need to print out just to next available grade slot in order to just get the first values and not the ones that we haven't used so far. Okay, but for each is handy if you're going through all of them for some reason.
That into the second for, is that the value that's in the array or the position of the array?
Which one? This one?
Yeah.
That's the actual value.
So if there was a string in that, you would put string?
This would be string, yeah. So if you had a string array of things, you could do that too. If you want to initialize a bunch of things, int array numbers is 5 minus 3, oops, minus 4, 6, 23 will work. And then if you want to print them all out, we would just do that and change it to, let's go through all of the numbers. How large do you think that array is?
4.
It's exactly 4. So in this case, you don't have to say new something. The compiler is going to figure out that you really mean there's just going to be 4 things, and we'll fill it to exactly 4. Okay, so that's a fixed size
Braces
array.
that way? You don't use the brackets?
That's the syntax for it.
Yeah.
Okay. You can do strings if you want a string array. Let's do some names. Put the braces in, and then do Fred, Sam, and Joe, for instance. And then you can do the same thing there of saying, let's go through 4, since you wanted to see it, string a name in some names. Whatever else you want to do in there. A name. Okay, so that also works. Run it, and there's all of the names. And the same thing, you can use that in a switch statement if you want. And so some names, sub 0, 1, and 2 are the values that are in there. What else can we do? Well, it turns out that you can also do fish array of all fish is new fish. I'm going to do this on separate lines, which is normally how you'd see it. I have fish in there yet? Thought I put them in. Oh, I just got to put them in the wrong package. Got it. And then we'll put a comma there. And we'll make several fish. And the trickiness here is that when you're done, probably have to put a semicolon. What have I done here?
The last fish point should have
I can never remember. Sometimes the syntax eludes me. All fish. Oh, this is only one fish. Exactly. So there's multiple fish. And I think that semicolon is required, if I remember correctly.
You also have one too many commas.
You'll typically see that last comma left there because people, when they're writing this, have the intention that maybe we're going to go along and add some other thing in there. And so most of the time it will actually be left, and the syntax allows for it. So it's just an easy way to, they all look alike.
It's inches, not pounds.
Okay. So that thing, that little thing actually comes in handy because if you've got an array list of fish,
Fishies.
let's do a couple import statements here. Then the problem with filling that array list is that you typically have to go fishies dot add all fish sub or put it this way, there's nothing that allows you to do, to get the fish on in the same nice, easy way as it happened here. Okay, I've managed to fill the array with values. You know, the 0 value in the array has that fish, the 1 value in the array has that fish. But there's no easy way to fill this array list other than to do them one at a time with an add method, which is sort of ugly. So one of the shortcuts here, just let me get rid of that thing there, would be to say for fish, a fish, in all fish, this is fishies. You can now do, in all fish. You could add the fish that way from the table. Okay? So the point of this thing is that really when you see it in code quite often, it's not used for itself, it's used really just to fill an array list. So it's a table of values that are going to be dumped into an array. We've seen a shortcut for that. What's the shortcut if you want to copy an array list? You can try to pass it as an argument, and so if you try to do something like more fishies here and pass in all fish. Oh, notice it will let you, if we pass in fishies, which is another array list, that's the one we've seen so far. That says use an array list to copy into another array list. You would think that you would be able to do this and put in all fish there and have it work, but no. Arrays are different than array lists, and so that isn't allowed.
Is it because they don't have the associated method to allow you
Yeah, they're just not the same thing. They're actually two different beasties. But there is a conversion utility, and the conversion utility has a really silly name. It's called arrays.asList, and you can say arrays.asList, and we'll just do the import statement for arrays, and that's the conversion. Okay? And so when I said idioms, we were going to see some idioms. There's a very specific Java-ism that says, I know all fish is an array, but use this function here. That's a static function like we've seen for the comparators we've been writing. Same sort of idea. Use that static function to temporarily think of this thing as being a list long enough that we can copy all of those values out of the array into the list where they belong. Okay, and so it's just a little conversion utility. If you've got an array of things and you want them dumped into an array list of the equivalent thing, that will do the job for you. Okay, so it's not the most obvious thing in the world. And there's also a conversion that goes the other way. If you've got an array list of things and you've got some idiot who insists on working with arrays directly, there's also a conversion utility that goes back in the other direction that's a one-liner that says, well, okay, if you really want this stuff pumped out of an array list into an array, here's a utility that'll do it for you. Okay, so the conversions exist in either direction, but normally this is the way you'll see it, just like I say, because there's no easy way to make a table of values like that and get them dumped into an array list in an easy manner. And with that, we're out of here for today.